Okay, so we now know how to get the server running and import data. Then the next part is of course using that data, and to use the data you first have to get at it. So I'll be going over that now first. Most of this I'll be using the air quality service for. I'll post a link in chat so everybody can follow along again and try out himself. But on the website under data nests, there are also the other sources that also have really interesting things in them. So the data model, I think now pretty much covered that. So I'll skip that for now. Basic requests we've also seen. So the index page, just the version number, then the type or the collection to get all of the type, and with the ID to get one of the type. That we also covered quite well. We didn't really cover the links yet, so they all follow the same pattern. At IoT ID is generally everything with an at in it is generally the server generated bits. So at IoT.id is the ID of the entity, and at IoT.self-link is the URL that this entity can be found at. Let's actually go to our air quality service to actually, oh great, oh that's wrong URL. Got scared a bit there a second. At IoT self-link contains the link that this entity exists at. And so that is basically the same with the ID in it. Then there's the things called at IoT navigation link. That's the links to other entities. And they can be either linking to a specific entity or to a collection. So if I have a thing, then data streams is also, that's why it's data streams, and the thing has multiple data streams or can have multiple data streams. But the link back is to thing, which is singular, because a data stream can only have one thing. So from these properties, you can also already see whether if you follow the link, whether you'll be getting one single entity or a list of entities. So that's for the related objects. Then tailoring responses, that's where things get really interesting. So if I go to this service and ask for give me all things, I get 100 things, but I can guarantee you there are more things in this service than 100. So first of all, we can get the count by saying $count is true. Technically, a server can already always automatically return the count, but if you specifically say it in the URL count is true, then the server must return the count. You have to be a bit careful. If you ask observations with count is true on this server, you will not be getting a response, because counting, this server has more than 300 million observations, and counting those takes too long. That's actually a known problem with relational databases, that counting items, especially when there are a lot of them, can be very slow. But counting things is usually not a problem. And this service has 4.3 thousand things. Of course, by default, it doesn't return me 4.3 thousand things, because that would be a huge document. That would be a huge document, and that's not very useful. Just a second. That was my son that also wanted to play along. That's the disadvantage of working at home. Right, I was saying, returning all those entities would be too big of a document, and that would not be useful. So the server by default usually limits the number of items you get back. But you can also say yourself how many items you want with the top parameter. So if I say top is 10, I only get 10 items. So if I'm not certain how big the items are or how many there are, it's usually a good idea to do a first request, especially when you're using your browser to discover a server, to do a first request with a rather low top, so you're not directly downloading megabytes of data. Of course, I just asked for 10, but there are more, and that's why the server generates me a next link at IoT next link. This next link will go to the next 10, or the next 10 in this case, because I have a top of 10, the next 10 items in the list. So there's a top of 10 and a skip of 10. And then I follow the link and I get the next, and I get item 10 to 20 or 11 to 20. And then it generates a new next link. As you see, the next link also contains all the parameters I've been using. So if I say top is 11, skip is 10, it'll actually say, okay, the top is 11 will be coming back here. And if I add again the count, it'll also say, well, okay, you wanted the count for the previous one, so the next link will also have a count. I can explicitly say count is false, and then it does not add the count, and the next link will also have that. So that's important because there are more items. For instance, sorting, order by. Let's go back to the first things. By default, there is no sorting order, so you might be getting your things in any order the database might like to return them, which is actually order that can change when you edit your entities. If you change an entity, it might end up at the end of your list or somewhere in the middle. Databases can do weird stuff when editing, and so the order by default is not specified. So order by, if I want to order by ID, then I get actually from 1 to 3. Of course, the default is ascending. I can also say, no, I want them descending. And then it goes from the highest ID to the lowest. I can order by any property, so I can also order by name. And then I get the station that starts happens to be named air quality station first. There are quite a lot of air quality stations. Let's go descending and start with the Z. Oh, they're all air quality stations. Oh no, so I was looking at the description of the name.
Exactly.
Sorry?
You're sorting by name, so the description is still always air quality station.
Yeah, it's, I was looking at the wrong one. There is actually a Zeubelboden in Austria. I can also sort, for instance, you can sort by any property. Whether all implementations support that is, of course, not guaranteed. But in Frost, you can also sort by properties. So you can also sort by the begin time, which might be useful if you want to know which is the station the oldest station that I have. So you can sort by properties / begin time. And then we've got a station that started in 1886. Is that correct, Kathi?
Yep, that's Sonnenblick. That's one of our oldest stations out in the Alps, and I think it was started by some monks.
Wow.
So we've got some decent time series lying around.
Indeed. And the youngest station is in Czechoslovakia, I think from 2000.
Slovakia.
And the Belgians also have a pretty recent station. So that's order by. Then the really interesting one is select, because you can see this is quite a big page, and especially when you do things like ordering by name, then maybe you don't want to see everything, all the other properties. So you can do select this ID, name, and that reduces the size of it. And you can quickly get an overview of which entities exist there. And you can add the description. Oh, there. No, don't start a new browser. Close. Then we go filter. Filtering is cool, because of course you don't always want to see everything. Let's add instead of description properties, because usually I end up filtering on properties. For instance, we have a country code in here. So I might be interested in, okay, give me all the stations that are from Denmark. So I can filter is properties slash country code equals Denmark. And bloop, I only get the stations from Denmark. I mean, now what? Tell me how many there are. There are 14 stations in Denmark. And here it is important that the thing I mentioned about next links, that they contain all the parameters. Well, because if I, for now, just say, okay, give me the first 5, you can see that the next link contains my top, my skip, my select. So the select is also kept, and the filter. So you actually, the next link is really the next set of the items that I have in my current selection and account.
Well, a short comment to the participants. If somebody can think of a query they would be interested in, type it in the chat and challenge Hylke to it. I've yet to find something he cannot manage to formulate.
Yeah.
I mean, what we can't do here, one of my favorite tricks he had was putting a threshold for a measurement value into the thing. So you could have in your monitoring facility a threshold for that station, and then do a query across the entire data model to please provide me all observations which go over the threshold which has been stored within the monitoring station.
Yeah. And while Kathi was saying that, I was looking up the observed property NO2, which is IoT ID, which has name NO2. That's good, because you can of course, now I've been showing how to filter based on entities of properties of the entities themselves, but you can also filter on things that are further away. So here we've got 14 Danish stations. Let's see how many of those stations measure NO2. So, and well, that means if the station measure NO2, it has to have a data stream with an observed property that measures NO2. So data streams slash observed property, and in that case it's the name equals NO2. And there are 13 stations. 13 of those 14 stations in Denmark measure NO2. So to go quickly back to the data model. So what I did, I was requesting things, and I was filtering based on the data streams of that thing, and then the observed property of that those data streams, and there the name. So only things that have a data stream that have an observed property that have the name NO2 were returned. So you can really filter across the entire data model. You could also, for instance, request all the observed properties that are being measured at a certain thing. Then you do the same thing, the same query, but the other way around. I've shown the equal, but you can also say not equal. So you can get everything that have all observed properties. There are all the stations that measure anything that is not NO2. And greater than, greater equal, less than, less equal. That's usually for numeric ones, but it would also works for dates in the phenomenon time, for instance, of your observation. I showed that you can combine filters with and, or not. And you can make complex things with parentheses. You can group things. You can use mathematics. That's also always an interesting one. For instance, the length of a string. Let's go back to our things and do just funny results. First of all, most of those functions also work for order by. So let's order by the length of the name. takes a bit longer because it has to calculate the length, but the shortest names is actually a station named AKH in Austria.
General Hospital in Vienna, Allgemeines Krankenhaus.
And that's descending. The longest name is that one. Austria has interesting properties. They have short names, long names. But you can also say, well, okay, only give me, you only filter stations that have a length of the name that is less than 5. That's only one, okay. Less or equal than 5. It's a little bit more. And I want to know how many there are. Oh, it's not a very few. 6, does that still not a lot? 7. Okay. There are 8 stations with a name less than 7 characters, or less than 7 or less fewer characters. 8. It's getting a bit more. Let's go to 10. That should yeah, 25. Now, most stations have an actual sensible name. You can also do matching of substrings and yes, indeed search for a specific string in your names. You can do also a bit of mathematics with rounding or ceiling or floor. And then, of course, it's an OGC standard, so there are lots of geospatial filters. Find me all the stations in a certain region, or all the stations within a certain distance of a given point. Things like that are also possible. And then there are, of course, functions for time. Interesting one is now, but I'll not go into, I'll get to the cool queries a bit later. Because there is also expanding. That's the second really cool feature. Because of course getting things is one thing, but if I want to put my things on a map, I also will need the locations of those things. So first let's reduce the size of my my returned thing, return data, ID, name. So these are the names of all my things, and now I want also the locations. So I say expand is locations, and that directly gives me all the locations for each thing. So this I could directly plot on a map. Of course, it's a bit big, so I want to have some parameters. Those locations should also have a select in it. ID, location, encoding time. There, which a bit reduced. There I have my things with the name and the location with just a encoding type, the ID, and the geometry in the location. And then I also want the data streams for that. And for the data streams, I want just the name, and then I get the names of the data streams with that. Most of these only have here, and this one has lots of data streams. And then for those data streams, I also want again expand with observations. And for those observations, I want to only one. And I want them.
Expand and it'll work better.
Say what?
Add an X to your expand and it'll work better.
Ah, yes.
Typo.
Thank you. And I want the order by is phenomenon time descending. Ah, of course. If you type in too long, you will get typing errors. Order by, that means I missed a $sign. And there's another typo somewhere, or order by, not order by. Being dyslexic doesn't help a lot. And there we go. I've got all my things with their location and the data streams and the last observation. And this you could directly put on a map and color all your things according to the results of your observations. And of course, in this case, I've requested all the data streams, but I could, for instance, also add a filter. I'm not going to do that because that will guarantee me making typos. I could say only give me the data streams for a certain observed property, because you can add all those query parameters, tailoring responses. All these query parameters are also valid inside expands. So inside an expand, you can also use top, skip, count, order by, select, filter, and expand itself. And that's once you get used to this, that's really powerful for your use cases, because you can actually make a request that gives you all the data you need for your use case in one request, almost regardless of whatever your use case is.
I mean, it's one request, but it's also nested within one object. I like the way it merges in other pieces. So you're starting at your thing object, and you've now packed the data streams and the observations into the thing.
Yeah.
So if you're now using a simple display tool, you have one thing object with the value attached.
Yes. Of course, that that makes it a bit tricky. How do I design my query? Because if I'm interested in observations, I could just query directly /observations. Doing that on this air quality service with 300 million observations is probably not the most useful thing, but it might be for a certain use case usable. You can start from your data streams and then expand your observations. Or you can start from the features of interest and expand observations. Or you could start from a thing and then expand the data streams and then expand observations. Or maybe you're interested in a certain observed property and from there go to the data streams and do the observations. That's all possible. And what you get back depends on where you start. So if I indeed start at observations and then say, okay, I want the observations and I want the data stream with that observation and the observed property, then I would get a flat result because I'm getting back a list of observations. And then for each observation, I would get a data stream. But if I have 1,000 observations of the same data stream, I would also get the data for that data stream 1,000 times, because for each observation, it will be expanded again. While if I go the other way around and ask a data stream with 1,000 observations, I only get the data stream once, and then in that data stream, all its observations. If I start with observations, I can no longer say, give me the latest observation for each data stream, because there is only one list I'm requesting on observations. And that means there is only one latest observation in this list. But if I start at the data stream and then expand observations, I can say, okay, give me all data streams. And for each data stream, expand the observations. And for this, give me the latest one, because each data stream has a latest observation. So this is this required to really get the hang of it. You need to practice a bit and get the hang of the data model and play around a bit with your data. So I've got two examples here. Starting from the observation, you basically get a flat list that looks a bit like CSV. And indeed, in Frost, you can actually say, okay, and give me it now as a comma-separated file. That works. But if you start from the things, you actually get a tree and a nice nested structure. So thing one, and then the data stream, and maybe the observed property, and then the observations of this data stream. And then the second data stream is nested in, also in the thing. So there you get a nested structure, which is usually a bit easier to handle. But there are also use cases where you do indeed just want all the observations and want to process it as such. Okay, looking at the time, I have to go a bit faster. Then there is something called a result format parameter that I have not mentioned before. This parameter can be used to request that the server returns your data in a different result format. There's only one standardized result format in the standard so far, which is data array, which can be used on observations only. So if I quickly go to a thing, let's go to a data stream. I don't know what this is, doesn't matter, with observations. So this is the normal way observations are returned. So for each observation, all the entities are fully spelled out. If I add the result format data array, then instead of saying the full name of each entity, each property, it just lists the properties once, and then it just lists a nested array of all the properties. And of course, in this case, there are lots of nulls, but if I combine that with the select is phenomenon time comma result, then it's a lot more efficient and a lot more efficient way to get your observations, smaller data size. Frost also has some extra extensions. You can get directly GeoJSON, which is useful if you have other GIS programs that you want to use your data in. I can give a quick example for instance, things. Of course, thing itself doesn't have a geometry, so I do have to expand locations for it to be useful. Locations. So this is the standard result format, and then I can say and standard result format is GeoJSON. And now I get flattened GeoJSON. So GeoJSON has a feature collection, and each feature collection has a bunch of features, and each feature is of type feature and has a geometry, which is has a type. SensorThings doesn't only do points, it also does other things. You can also have polygons or lines, and then it adds all the properties that of my entities and my queries in the properties of the GeoJSON. So this is something you could feed into, for instance, QGIS. And then lastly, you can also get your data as comma-separated values, which can be very useful if you want to export your observations somewhere else. So if you're using this query, all the observations for a given data stream, and the data stream ID and name, and then you get a CSV with the data you requested. And then I have a bunch of example queries that you can look over. Including the give me everything one that just expands almost everything, and you get a big document. But I'll leave that as an exercise, given the time I'll leave that as an exercise for the later readers. So then we are on for the last bit. Do we have a Mentimeter part in between, Kathi?
We probably should. Wait. Let me quickly set that up again.
Then I should stop sharing. See the chat. Okay, that was Kathy's question.
Okay, you should now be seeing my screen again. And next question to all. So I think now you've all gotten a far better overview of what the SensorThings thingy can really do. Do you still think it supports what you need? How do we have 5 people, 6 people answered not yes or no? Did I provide a maybe there?
No, it's only yes and no. Maybe your maybe the painting is broken. Yeah, there it goes.
Much better. Okay. So people are still, wait, nobody's saying no anymore. So everybody who was terrified left the webinar, and the people who are left are happy with it. Let me counter check our audience size if I can.
28.
So some people are still being a bit quiet on this. Okay, but it seems like the people willing to respond are also willing to play with this technology, or at least think it would help them. Next question. I mean, the underlying question is who managed to follow all of the tricky bits which Hylke was presenting to us?
Of course, I do have to say here that this was a quick introduction, and there's a lot possible, and it's pretty hard to take that all in and quickly see, well, does that support all the questions in my use case? So I wouldn't be surprised if someone doesn't really know it yet.
I mean, to date, have I managed to figure out a query you couldn't formulate?
Yes, there are a few that are not possible, but that's the more exotic ones, where it's partly also, if you would put the data differently in the server, it might be possible to do it.
I mean, it's even there. I mean, one then needs multiple requests.
Yeah, it might need multiple requests. That's usually that happens when you have fancy things with your feature of interest. If you have a feature of interest combined with moving things, and you want to get the latest observation from multiple data streams for one feature of interest, because that's not possible, because there is no link between the feature of interest and the data stream. But those are really edge cases where you can get the data, you have to do more than one request.
Okay, but it seems that this message has gotten through, that just about everything you need, one can really query directly here. Next question, error handling.
No, we have not even mentioned that yet.
Well, you did show some errors, which
There's yeah.
Going. I think for some reason my computer is getting lonely. Okay, one person caught how you handled the errors, and the others are as confused as I tend to be, of saying, oh my God, what did I do wrong? And then I realize I wrote extent without a T.
Yeah.
Or I forgot yet another ampersand. I mean, this is one bit to everybody. It does take a while to get your brain around these formulations. One of our next steps, if we can find the project for it, would actually be to create a query generator. Again, it won't cover the tricky edge cases, but at least for simple bits, we'd like to foresee something which will support you in building these queries. The cool bit, which we'll be presenting in a moment, that when we're past this, is we have gotten a cool, simple way to map this stuff. And there you don't even have to deal with most of the errors, because that's covered in the code. Okay, so error handling is something which we really need to do some more homework on.
Well, we didn't explain it, so people are very honest. It's not clear how to do it because we didn't cover it in the tutorials.
Okay, and let me go through this bit now also, because then we're done with our questionnaires. Okay, first one managed to access it. Several people have managed because we have been getting data in our playground.
Yeah.
Okay, so there we seem to be very positive and are performing to what people would want. That's one bit which is actually missing in the API specification. We would need real,
Yes.
Are there backlinks there to the standard, or probably more ideal would be also a backlink to a tutorial, since as we've heard earlier, reading the standard is interesting, but if you really want to use it, it's not the best place to start.
And this is also something that is improved from version 1.0 to 1.1. Since in version 1.1, the index page actually has the list of conformance classes that the server implements, and those should at some point link, and when the 1.1 is finished, should link into the documentation or the standard itself.
Okay, so here we've got, I mean, a lot of people did find the documentation regardless. A bit more homework here would be welcome, but that's in the pipeline anyway. And I would say that's it. Thank you very much for the survey participation. And now, as a final part, Hylke will show you how to take all of this cool data and easily pop it onto a map.
Yes. So mapping, we all love maps. That's why we are doing stuff with geospatial data. So given the time, I don't think we will get completely through this tutorial, but if you do it at your leisure later, this is actually the map you will be creating. And this is from our demography endpoint. All the countries, the color is the population density. So we can see that the Netherlands is quite densely populated. Let's make it a bit bigger. The Netherlands is quite densely populated with 504 people per square kilometer, and Norway is pretty empty with 17 people per square kilometer. More cool things is if you zoom in on this map, it'll subdivide by NUTS region, by smaller NUTS regions. And here you see things like, this is Berlin. Berlin is very densely populated. This is not densely populated. And if you zoom in, you can very nicely see all the areas around Berlin. There's basically nothing. And this is the Ruhrgebiet, lots of cities and big industry there. Paris is also a thing. I was a bit surprised at how low populated the rest of France is. And also in Spain, you clearly see the big cities, and here also around the coast, there's lots of cities. So that'll be the end point of the tutorial. And you can actually do all this with just a browser and a text editor. You don't even need a web server for this. So basic mapping, we need an HTML, start with an HTML page. So here I've got a bit of HTML, and I'm going to copy that. And then I'm going to my file browser. So it would be Windows Explorer on Windows. I'm on Linux, a bit different. And I say, create me a new empty document. Tutorial map.html. Oh. And then I open that in a text editor. So Notepad++ would be my suggestion for Windows users, but the normal Notepad nowadays is also quite doable. And there, and I paste my HTML, and I save. And then I go back to here to my file browser, and I open that in my web browser. And there we've got our base page. There is no map yet because we've not configured the map to be there. Let me open this, pull this in my other tabs so I don't get too many tabs open. There's nothing to see there yet because we've not added that yet. It's basically a placeholder. It has a div, an item where the map has to go, and there's an item where the JavaScript will have to go, but it's not filled in yet. If you don't want to copy it, there's also a download here. You can open that and you'll see the page as well. So to activate a map, we have to add a little bit of JavaScript to the base script tag. Oh, I did add all the necessary plugins for leaflet. So the basics are there for the map. Now I need to actually make a map. So I go back to my text editor, and inside the JavaScript bit, I paste this, I save, go back to my web browser, and I reload, and voila, we've got a map. This is just OpenStreetMap's background, but no data yet. So let's first add some. STAM is our SensorThings API Mapper. It is a leaflet or open layers plugin that can do SensorThings. So now we add a layer to our map with the air quality data. So I make a call to STAM. I say the base URL of the data is the air quality server.
Look, should we quickly introduce STAM? That you've just taken out of nowhere.
Later.
Okay.
I want the things to clusters because there are quite a lot of stations, 4,000. I don't want to download all of them. I only want to see the stations if there are less than 10 grouped in an area. And I want my queries to start at things. So I add that to my JavaScript. Save, and I reload my map. And now we've got numbers on the map. There's quite a lot of air quality stations, except on this island. There's only one station there, so it's directly shown. And in the north of Norway, there are also not that many. If I then zoom in, the numbers get smaller until they're below 10, and then the station starts showing up. Since I'm in Karlsruhe, I'll click on a station, and then I can say, this is the data streams that exist for this station, and then I can click on NO2. And now it downloads all the observations for NO2, which is 3 years. This takes a while, but here are all the NO2 stations, or the NO2 measurements since the January of 2018. Now, downloading all the observations each time I click on it is not that useful. So I only want the observations for the last month. So I add a little option to STAM. When I plot it, I want the start date to be now minus, this is 1 month in milliseconds, and the end date is now. So I add that bit to my STAM configuration. That goes here. I do have to add a comma. And then I reload my map. Now my OpenStreetMap, there it is. I zoom a bit in on that same area, more or less there. It was Karlsruhe, NO2. And now it only shows 1 month, which is a bit more useful for hourly air quality measurements. So that's how easy it is to get your first data from a SensorThings API service on a map. So what is STAM? STAM is the SensorThings API Mapper. It has a GitHub page. It's created by a student of Kathi, an intern, in, what was it, 6 weeks?
He managed to slap that together over the summer.
Exactly. I think it was 6 weeks or so he had at the time.
And he's not even a student yet. This kid is 17.
Yeah. And we created this one because there are plenty of ways to do maps. But one of the things was that what you really need, if you have many data, lots of data, is this loading depending on how many things you have in your area. Because you can imagine, well, this server only has 4,000 stations. It's not too bad. But if I go to another example, in data nests, Franco-Germanic flow, there we've got the surface water quality stations in France. And France has a lot of surface water quality stations. And here this map is not yet using STAM, and here it is loading 19,000 stations. And eventually it'll get there, and then it'll work fine. But until it's there, you're waiting. And that's why one of the things in STAM, what that STAM can do is, instead of just directly downloading all the things, it takes the OpenStreetMap tiles and it first asks how many stations exist in this tile, and if by doing a count query. And only if there are fewer than 10 or configurable amount, it will actually request the stations. So now it's finally done, and yeah, here you see indeed France has almost 19,000 things in that area. So that's why STAM now exists, because it can do loading based on the number of things in an area.
Short input. There's a question in the chat asking if you've tried using WebGL.
I am not familiar with WebGL, but in this case, for this loading, it's really the loading of the data that's the problem, so not the displaying. If you have a lot of things, and especially when you have not point things but polygon things, you get a large data size, and you have to download that to your browser before you can display it. So yeah, it's the initial loading that's the problem in many cases.
I mean, the power of the STAM application is that it also it has integrated the SensorThings logic, so it takes a lot of the query formulation away from you.
Yeah, so it's I mean, Leaflet can also show lots of points. That's not a problem. It's the loading of the points that's the slow part. You don't want to, on one hand, you don't want to overload your server, especially if you also do things like directly expanding all your data streams and asking for the last observation. If you're doing that in the surface water case with 19,000 stations, and then each station has up there, in that case, up to 1,500 data streams, the amount of data that you have to transfer before you can even start displaying it is the problem.
So it's nicely taking the logic away. It's first counting how many objects will there be there, and only if it's a displayable amount of objects, it'll even really get the individuals, or it'll just give you the count. It also does the tiling nicer. That, I mean, Leaflet open layers can do tiling, but they don't do it based on standard units. And the grouping keeps shifting around, and that we've adjusted, that we're focusing on the open layers tiles. And we always first query the amount of stations within a tile, then decide to display depending on how you've configured the application.
Yeah. So the next bit, looking at the time, I can't actually go too far in it, but I do want to show a bit about the data model here. Is exactly this case of polygon things. In our demography use case, we have demography data. So that was our map that was in the this map exactly. So if I click on a country, I get all the demography, age, gender, cut downs, population density, things like that, with shapes. And those are all in the SensorThings API. So if I look at this server and ask, okay, give me for the country code Germany, give me the location and nuts level 0, which is the top level of 0, I get Germany. I can then go to nuts level 1, which is the Bundesländer in case of Germany, the states in Germany. There are 16 of those, and then I can go to nuts level 2. There's 38 of those, and then I can get to nut level 3, and there are 401 of those. And those are, of course, all for the same for Germany. So if I were to load that in a standard naive map, you would get overlapping things, and you would actually have 4 layers deep of overlapping things. That's not very useful. So one of the other things that STAM can do is you can set for a zoom level which query should be used to load things. So that's why it is possible in this map that if you zoom in, you start out at nuts level 0, and if you zoom in, it'll go to nuts level 1 all the way until I zoom in a lot. You get the smallest nuts level, which is I think 3, which is the smallest Gemeinde, I think. So we can have a query that loads those nuts levels. But then let's have a look at locations, because that's also special in the servers. If I load the locations for Germany, I see it takes a while, and then I get a very big document. So let me close the chat. A very big document that actually has, it's one entity, as you see, on one thing, because Germany, there's only one Germany, fortunately. But there are multiple locations in this and serves. So Germany has 5 locations. And the difference here is the scale. The Eurostat supplies this data in these nuts regions in 5 different scales, from 1 to 1 million to 1 to 60 million. And of course, looking at the 1 to 60 million and looking there at the location, we get 3 decimal points for our geometries. And you can see it a bit at the size of my scroll bar. It's not so long. And if I look at the 1 to 1 million, and there look at the details, I get more decimal points, and it's a lot more points. So when I'm in a very zoomed out state, I probably don't want to download the highest level, because, and on the other hand, if I'm in a zoomed in state, I don't want a lower resolution scale. So the other thing that this map does, and you can see that in these islands, if I zoom out, you'll see them vanish. Because at low zoom level, they don't bother adding the islands. And if I zoom in, you get more detail until you get nice polygons for each island. So that's the other thing that this tutorial then goes over is how can you configure STAM to change the zoom level or change the location that is loaded based on the zoom level, and change the nuts region based on the zoom level, so that when you're zoomed in, you get the smallest nuts region in the highest resolution, and when you're zoomed out, you get the very coarse nuts, or the highest tier nuts level in a very low resolution. But unfortunately, we do not have time to actually make all that. But if you go to the tutorial, you will end up with this map, colored based on the population density, and loading nuts levels based on zoom level, and resolution based on zoom level. So that concludes our mapping tutorial as well.
I would say we have shown what we have to show, and would now open the floor to any and all questions, hoping that we haven't confused everybody to the point of silence.
Is anybody still left? Yeah, still 27. Good. Yes, I think also a very important aspect of SensorThings that many people overlook is that you do not have to have point things. You can have polygon things and line things. And geospatial querying can also deal with that. So if you have polygon things, you can actually say, give me all the polygons that overlap this point. Give me in the case of rivers, give me all the rivers that crossed through this region. Those are all possible.
I mean, the other advantage of this little STAM library we built, I mean, it covers basic use cases. We're fairly sure if you then are setting up your site, you will need more. But it's a beautiful starting point which foresees all of the tricky bits. So I think if you start with that as a software, you may end up re-implementing it all. But you've got clear code examples which show you where are you likely to run into problems and what one can do about it.
Yeah, and at the API for Inspire site, there are also all the other use cases, and most of them also have examples that either in STEM or in other content management systems that visualize the data.
I mean, a further point where I'd like feedback now based on the adoption of SensorThings API and Inspire. Does anybody see issues why this would cause a problem?
And I think we can turn on microphones for this. I mean,
yeah. Who can let people speak?
Or can people just unmute themselves?
We can unmute ourselves, I think.
Yeah. Very good. Please speak.
Everybody is too impressed to speak.
They're just tired.
I think we'd need to think about that. Nothing I could come up with right now, but I guess we would first need to investigate that before we could really answer.
Well, I mean, further feedback to everybody that the API for Inspire project is running until next February. And part of our job is supporting the wider community with the uptake of these technologies. So if you have issues, get in touch with us, check through what all we've been providing on the website. Also provide us feedback if our tutorials are confusing. I mean, we've done our best to make them understandable, but it's up to you if you can understand it. If you can't understand it, it's probably our fault, not your fault.
Yes, and that's also the reason why I made them always on the website, so you can follow them at home at your leisure. But feedback is very much welcome.
Kathi, Hylke, if I can just say a couple of closing words. I'm Marco Minghini. I'm supervising the API for Inspire project on behalf of the ELISE and also the JRC Inspire team, together with my colleague Alexander Kotsev, who I think had to leave some minutes ago. I just would like to thank Kathi and Hylke for this great workshop. I believe it has been really great. They managed to teach us SensorThings API in one single afternoon, or at least they managed to give us a very clear idea of the potential of this technology. I think we are now all looking forward to the MIG meeting next week, where hopefully OGC SensorThings API as an Inspire download service will gain the status of an endorsed Inspire good practice. As Kathi said, if you want just to stay updated with the results and the news on the project, contact us or contact them, provide feedback, if any. On the workshop, of course, check the website that we have been using today, but also follow the ELISE communication channels, where we will also disseminate the results of the project, and in particular the final technical report in early 2021. And finally, thanks also for all the people who managed to attend the workshop and to stay until the very end. This is really appreciated. So thanks again.